Welcome back, math students. Today we're going to be doing the sine rule. If we have a look at our formula sheet, it's given as sine A over A, sine B over B, and sine C over C. You can see what I've done here. I've encircled either these two, or these two, or those two, and I'll show you what that means. Solving triangles means we need to be looking for sides or angles. So if we're looking for an angle, we put the angle on the top. So what that means, if we're looking for this, we need to be given two sides and an angle in order to find that side. Two sides and one angle, which would mean we are looking for another angle. If we're looking for a side, we put the side on top. So what do we need to be given? We need to be given two angles and one side. So if we're given two angles and one side, we will be looking for another side. I'll show you how all this works in an example. The sine rule is used when an included angle is not present. When do we use the included angle? Only for the area rule and the cos rule. Because the angle is included between two sides, I call it the squishy angle. The sine rule is best used when two sides and one angle are known, like over there, two sides and one angle, and it means we're looking for another angle. Or two angles and one side are known. And I'll be illustrating that in example 2. Two angles and one side are known, and we have a look for the unknown side. After we've done the examples, we will do the proof after that. So here I'm going to illustrate the two cases. But before we do that, I like to think of something. In the olden days, each of us, we had a family crest. And it looked something like that. I call it a shield. So the shield is called a side angle pairing, a side angle pairing. And unfortunately, what happens during the battles of our families, we possibly lost one of these, and we could be looking for that. So what does that say? If we have two sides and an angle, we could be looking for an angle. Or, remember, the sine rule is used for a side angle pairing, a side angle pairing. And unfortunately, if we lose one of the, let's put arrows heads on here. If unfortunately we lose one of these, we'd be looking for that unknown component. So in this case, we'd be given two angles and a side, and we'd be looking for the unknown side. So let's have a look at this illustrated example. Given one side, let's choose any side, it doesn't make any difference, and two angles. So let's see what we have. Notice here is something, this I call the coat of arms, and whenever we have a coat of arms, we do the sine rule. So let's see what's given. Whenever we have a tick, I put an arrowhead. There I put an arrowhead because it's known, and notice the side opposite the angle is unknown. There we have our coat of arms, and that is the sine rule, and I'll illustrate that with examples. So here we have our side angle pairings. We have one side and two angles, and we are looking for the unknown side. Let's call this NOP. Given two sides, so let's put any two sides here, and one angle. Remember, we cannot put the included angle or the squishy angle, so I cannot go and put it that side. I can't put the angle over here, so let's put it over there. So let's have a look. We have a side angle pairing, and there is a side and opposite, it is angle P, and then it's unknown. And notice we have a side angle pairing or the coat of arms, and here we can use the sine rule. So I'll illustrate these two examples by means of values and triangles in the next video.